Last time, we saw how the parasitoid wasps use their hosts as a source of food and protection for their developing larvae, so we already know that parasites are capable of doing some pretty crazy things to their hosts. But what if I told you there was a species of parasite that had the ability to functionally replace an organ of the host? Hi, I'm Jana, and this is the second episode of my series, Not Your Average Parasite, where we challenge our ideas of what makes something a parasite by looking at some examples that are kind of freaky and truly unique. Today's example is definitely not your average parasite. This parasite lives in water, but it isn't a fish. In fact, it's in the same phylum, Arthropoda, as the wasp from the last episode. And even though it lives in water, you're unlikely to see this parasite swimming around. You're most likely to find one by looking inside the mouth of a fish. Today, we're looking at Cymothoa exigua.
Please, no! 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 No!
Pretty gross, right? So what are they? To me, they sort of look like roly-poly bugs, or you might know them as pill bugs or woodlice, that you see in the dirt when you turn over a rock. This makes sense since they're actually pretty closely related. Let's take a look at how biologists have classified Cymothoa exigua. For starters, they're animals, so they're in the kingdom Animalia. They're in the phylum Arthropoda and the subphylum Crustacea. Yeah, like crabs and lobsters. They're in the class Malacostraca and the order Isopoda. They're in the family Cymothoidae, which are a group of parasitic isopods. Our specific focus today is on a member of the genus Cymothoa, the species Cymothoa exigua. So, where do these parasitic isopods live? As we can see in this figure, the highest species diversity of the cymothoids is in the tropical regions of the central Indo-Pacific Ocean area. However, there is also quite a bit of diversity in the western Indo-Pacific, northern Pacific, northern Atlantic, and tropical Atlantic Ocean areas. The lowest cymothoid species diversity is found in the cool waters of the Arctic and Antarctic regions. There are also some freshwater cymothoid species found in Africa, Asia, and South America and the Amazon, but the distribution of these species isn't well known. So, how does Cymothoa exigua behave like a parasite? For starters, its primary targets are teleost fish, which are a group of bony fish that includes things like tuna, salmon, and trout. But there have also been reports of them parasitizing chondrichthyan fish like sharks, jellyfish, cephalopods, crustaceans, and amphibians. The way that Cymothoa exigua acts as a parasite is where things get really weird. The female isopod enters the mouth of the target host fish and begins eating the blood vessels that supply the tongue. The tongue withers and dies off due to a lack of a blood supply. The female then uses her hook-like back claws, called periopods, to attach to the muscles at the base of where the tongue once was. This is how the parasite replaces the tongue of the host. Once it has replaced the tongue, they sometimes feed on host blood or fish mucus. But how did the parasite get into the host? What does the Cymothoa exigua life cycle look like? Cymothoa exigua is a protandrous hermaphrodite. This means that it starts as a male and can change to a female. The free-swimming youth stage of this parasite is called a monca. The monca is what finds a host to parasitize. Once the monca has found a suitable host, it enters through the host's gills and develops into a juvenile that functions as a male. If there is no female present when the parasite enters the host, it matures into a female, eats the tongue blood vessels, and attaches where the tongue was. If there is a female present, the male will attach to the gill arches in the mouth and will fertilize the female. The female holds the developing eggs in a pouch called a marsupium. The offspring hatch inside the marsupium, molt a couple of times until they reach the monca stage, then eventually leave to search for their own hosts. Interestingly, aside from their tongues literally dying off, the host fish doesn't seem to be harmed by having the parasite in its mouth. It can still eat just as well. In fact, research has shown that there is no difference in body weight between parasitized and unparasitized fish. A difference in weight only becomes apparent when there are multiple parasites in the mouth of a single fish. Thanks for watching the second episode of Not Your Average Parasite. Today we talked about Cymothoa exigua, a parasitic isopod that kills off and replaces the tongue of its host. In our next episode, we'll talk about another weird, kinda creepy parasite that is known as the vampire fish.